In this video, we will show how to integrate the information required to select the conductor size for motor control centers, MCCs. The selection of conductors for motor control centers is based on the requirements of Section 430.24 of the Mexican Official Standard NOM 001 Std 2012. This section is titled Several Motors, or Motors and Other Loads. It states that conductors supplying several motors and other loads shall have an ampacity not less than the sum of the following four elements. 1.125% of the full load rated current of the motor with the highest rating, as determined in Section 430-6, 2. The sum of the full load rated currents of all other motors in the group, as determined in Section 430-6, 3.100% of non-continuous non-motor loads. 4.125% of continuous non-motor loads. The selection of the MCC feeder conductor will be performed according to the loads it supplies. The Sizer Electric software groups all circuit loads that share the same description in the MCC tag field and associates them with the equipment identified by that same equipment tag number. Once the association is complete, the software sums all the loads, identifies the largest motor, and applies the corresponding increase factor to it, namely 25% of its rated current. Let's look at an example. We will enter 4 motors connected to 01 CCM 01. These motors must be registered with their technical data and their respective power ratings. In robust industrial systems, it is common to have one motor in operation and another as a standby in case the primary motor fails. To account for these situations and avoid oversizing the MCC, the motor circuit includes a checkbox located to the left of the equipment tag field. When this checkbox is selected, the motor is included in the calculation of the total MCC current. If the checkbox is left unselected, the circuit is still associated with the MCC, but its current is not included in the calculation. This is achieved by multiplying the motor current by 0, as will be explained later in the MCC associated load factors. As shown in the grid, we now have 4 motors connected to MCC 01 CCM 01. Next, a new circuit should be created for the MCC. Enter the circuit number. For this circuit, the equipment tag field must be filled with the tag 01 CCM 01. Then select MCC in the load type field, and subsequently select the system voltage. With the equipment number, voltage, and MCC load type defined, the software will search for all current and future loads that contain the tag 01 CCM 01 in the MCC or switchgear field and will associate those loads with this MCC. Note that when selecting the power field, a message is displayed indicating that this value has been updated. A pre-filled value also appears, which cannot be edited directly. This value represents the sum of the power of the associated circuits, including the current increase percentages. To verify the power of the circuits associated with the MCC, click the button with 3 dots located on the right side of the field. The window that appears will display, in the upper grid, the description of the loads associated with the MCC. That is, it will show the loads that, at the time they were entered, were assigned the tag 01 CCM 01 in the MCC field. The first column of the grid shows the tag of the circuit associated with the MCC. The second column displays the circuit equipment current. The third column shows the factor applied to the circuit load current, and the last column identifies the final current. This value is the product of the load current and the calculation factor for each load. The calculation factor can have 3 values. Factor 1.0 for circuits correctly associated with the MCC. Factor 1.25 for the circuit or motor with the highest load. Factor 0 for circuits with calculation errors, circuits with a voltage different from the MCC system voltage, and circuits where the equipment tag checkbox is disabled. To identify the origin of the factor, place the mouse over the circuit row and click on the factor field. A tooltip will appear indicating the source of the factor. At the bottom of the grid, there is a field labeled Total Current, which shows the sum of the final currents. This current will be used to calculate the power in kilowatts, which serves as the basis for selecting the MCC conductor. The following 2 formulas describe the calculation of the power associated with the MCC, expressed in kilowatts. This power is calculated by summing the final currents of the loads associated with the MCC and multiplying by the system voltage and the square root of 3. On the last line of this section, there is a field that allows adding or subtracting load from the MCC, expressed in kilowatts. This field can be used to include future loads or to add single-phase loads to three-phase MCCs. Since the MCC load calculation is directly affected by the power of each associated load, whenever the load of the circuits associated with the MCC is updated, the system will display a message indicating that the MCC load will change accordingly. Click the Accept button to close the window. Next, complete the circuit installation information and click the Calculate button to select the MCC conductor. Because the current and future loads of the MCC named 01, CCM, 01 are linked to its feeder, any modification to the power of these loads will trigger a system message notifying that the MCC load has changed. When the MCC circuit is selected again, the feeder will be updated with the new list of loads. Finally, the descriptive calculation report for the MCC feeder can be generated by selecting the circuit and clicking the Calculation Report button. Within the calculation report, section 5.1 will display a list of the equipment associated with the MCC that was used to determine the total current. In the tabular reports, the MCC load will appear as the total power expressed in kilowatts, and the total current value will be the sum of the load currents after applying the corresponding factors. These are the basic steps for calculating an MCC feeder using Sizer Electric software. For detailed information, please consult the user manual under the Help option or review the help files included in the same section. Remember that online help is always available by pressing the F1 function key on your keyboard. Thank you for your attention. We also recommend watching the complimentary videos on conductor selection, cable tray and conduit selection, and grounding grid design to gain a complete understanding of the Sizer Electric software.